There is a specific moment, not a gradual process, not a slow fade, a moment, measurable, physiological, happening inside a bird's brain in real time, when something shifts. When the animal that has been watching you for weeks or months crosses a threshold and files you under a completely different category than it did the day before. You have probably felt it from the outside, without knowing what you were feeling. The day the chickadee stayed on the feeder when you walked past, instead of flushing. The morning the cardinal kept singing when you opened the back door. The afternoon the robin didn't move when you crouched down to pull weeds 3 foot from where it was foraging. You felt something change. You just didn't know what. What changed was chemistry, measurable, specific brain chemistry, and understanding what actually happens inside a bird's brain in that moment changes the way you understand every interaction you have ever had with a wild animal in your yard. Welcome back to Backyard Bird. Subscribe before you leave, because today we are going somewhere most people never get to go. Inside the brain of the bird at your feeder, in the exact moment it decides you are not a threat. What the neuroscience actually says, what the hormones are doing, and what the bird's brain has to do before it can ever let you in. Stay until the end, because the last thing we cover is the one that most people find hardest to believe, and it is the most important thing we have ever talked about on this channel. Number 1, the threat detection system that runs every second of a bird's life. Before you can understand the moment a bird decides you are safe, you have to understand what it is running away from. What the baseline state of a bird's nervous system actually looks like, because for most people the answer is surprising. A wild bird is never fully relaxed. Not at the feeder, not in the nest, not asleep. Its nervous system is running a continuous threat detection cycle every second of every day, scanning the environment, evaluating every movement, every shadow, every sound, and making rapid probability assessments about whether any of it signals danger. The structure responsible for this is the amygdala, a small region deep in the brain that processes fear and threat. Birds have an amygdala equivalent called the Arcopallium, and in birds it is proportionally larger and more active than in most mammals. It evolved this way for good reason. A bird that relaxes its threat detection for even a few seconds in the wrong situation does not pass on its genes. Researchers at the University of California studying fear responses in birds found that the Arcopallium activates within milliseconds of detecting a potential threat, faster than conscious thought, faster than any deliberate response. By the time a bird consciously registers that something is there, the stress hormones are already flooding the bloodstream. The primary hormone in this system is corticosterone, the bird equivalent of cortisol. When a threat is detected, corticosterone spikes, heart rate increases, blood is redirected from the digestive system to the muscles. The bird is ready to fly before it has decided to fly. This is the system that every bird in your yard is running every moment it is there. The cardinal at your feeder is not enjoying his seed the way you might enjoy a meal. He is eating while simultaneously running a continuous background threat assessment of everything within his visual field. Every time you move, you enter that assessment. Every time you appear at the window, the system reevaluates. Understanding this is not depressing. It is the starting point, because what happens when a bird decides you are safe is the story of what this system learns to do differently, specifically only for you. Number 2, what the brain does with a familiar face. Here is where the neuroscience becomes genuinely extraordinary. The research on individual recognition in birds, most famously the crow studies at the University of Washington, but replicated across multiple species, established something that seemed counterintuitive at first. Birds do not just learn that certain situations are safe. They learn that certain individuals are safe. The recognition is face-specific, individual-specific, and stored in long-term memory in a way that persists across months and years. The brain structure responsible for this is analogous to what humans use for facial recognition. In birds, the Arcopallium caudolaterale, the avian equivalent of the prefrontal cortex, plays a central role in associative learning and memory. This is where the bird stores the learned associations that override the default threat response. What happens when a familiar, safe human appears is this. The Arcopallium begins its threat activation because that is always the first response. But almost simultaneously, the memory system sends a suppression signal. Previous encounters with this individual, pattern match found, threat level low. The corticosterone spike is blunted. The heart rate does not climb as high. The flight response does not fully engage. This suppression becomes faster and more complete over time. The more encounters a bird has had with a specific person behaving safely, the faster and more completely the memory system overrides the threat response. What looks from the outside like the bird becoming comfortable with you is actually the bird's memory system becoming faster and more confident at suppressing its own alarm. What is remarkable about this process is its specificity. The suppression is not generalized. A cardinal that has learned your face does not suppress its threat response for your neighbor. It does not suppress it for strangers who enter your yard. The suppression is keyed to you, your specific face, your specific movement pattern, your specific behavioral signature. If you change your appearance dramatically, a large hat, an unfamiliar coat, the recognition can temporarily fail, and the bird will treat you like a stranger until the match is reestablished. The moment the bird stays on the feeder when you walk past, that is the moment the suppression became faster than the flight response. It is a neurological threshold crossed in real time, built from every previous encounter you have ever had with that specific bird. Number 3, the role of corticosterone and why stress is the measure of trust. Researchers can actually measure how much a bird trusts a specific person, not through behavior alone, through blood chemistry. Studies on wild birds in residential gardens, published in journals including Hormones and Behavior, have measured baseline corticosterone levels in birds that regularly encounter specific humans. The finding is consistent. Birds with extended exposure to non-threatening humans show measurably lower baseline corticosterone in their bloodstream than birds without that exposure. The stress hormone drops chronically, persistently. This matters enormously for the bird's well-being. Chronically elevated corticosterone, the kind that comes from living in a constant state of high alert, suppresses the immune system, reduces reproductive success, and shortens lifespan. A bird that has learned to lower its threat response around a specific trusted human is not just behaving differently, it is healthier. Its immune system is less suppressed. Its body is spending less energy on the fight or flight system and more on digestion, immune function, and long-term maintenance. The person who has built trust with the birds in their yard is literally improving those birds' health outcomes, not through the food alone, through the consistent, predictable, non-threatening presence that allows the bird's stress system to operate at a lower baseline. Think about what that means. The cardinal that has been coming to your yard for 3 years does not just tolerate your presence. Your presence specifically is associated in its brain with a lower corticosteroid state, with something closer to ease, with a yard where the threat system can run a little more quietly. That is not a metaphor. That is measurable brain chemistry. Number 4, the dopamine signal. Why the bird keeps coming back. Trust is built through the suppression of the threat response, but something else is happening alongside that suppression, and it is what makes a bird not just tolerate a person, but actively seek out their presence. Dopamine, the same neurotransmitter that drives reward-seeking behavior in humans, drives it in birds. When a bird finds food, dopamine is released. When a bird successfully navigates a social interaction, dopamine is released. When a bird experiences something it has learned to associate with safety and reward, dopamine is released. Over time, the familiar human who provides food, who is predictable, who does not trigger the threat system, that human becomes a dopamine cue. The bird's brain has associated this specific person with positive outcomes, not in a vague way, in the same specific neurologically precise way that any learned reward association works. Research on corvids, crows, and jays has shown that birds will actively seek out humans who have previously provided positive interactions, even when food is not present. The seeking behavior is driven by the dopamine system, by the brain's reward prediction mechanism, anticipating a positive outcome. This is why a bird that trusts you will choose the branch nearest to you out of all available branches, why it returns to the feeder while you are still standing next to it, why a chickadee that has learned your face will come towards you when you appear rather than away from you. Snorts. It is not affection in the human sense. It is something more precise and in some ways more remarkable. A wild animal's reward system shaped by millions of years of evolution, incorporating a specific human into its map of where good things happen. Number 5. The moment itself. What is actually happening when the threshold is crossed? So, what is the exact moment? What changes between the day the bird flushes and the day it stays? The answer is a ratio. The ratio between the threat suppression signal from memory and the threat activation signal from the Arcopallium. For most of a bird's relationship with a given human, the activation is faster and stronger than the suppression. The bird flushes because the alarm gets there first. At some point, and researchers believe this happens incrementally across multiple encounters rather than in one dramatic crossing, the suppression signal catches up. It becomes fast enough and strong enough that the bird's flight threshold is not reached before the memory system has already evaluated the situation and downgraded the threat level. That day the bird stays. From the outside, it looks like a small thing. The bird just didn't fly away. From the inside, it is the culmination of a neurological process that has been building across every encounter you have ever had. Every morning you appeared to Gindo, every time you refilled the feeder, every time you moved slowly and didn't lunge or grab or frighten, every one of those encounters laid down a slightly stronger suppression signal until one day the signal was strong enough. The bird did not decide to trust you in that moment. It decided to trust you in every moment that came before. That day was just when the math finally added up. You have been part of a neurological process you did not know was happening. Every morning you stepped outside, every slow movement through the yard, every consistent, predictable, non-threatening appearance at the feeder, all of it was being recorded and processed inside the brains of the birds around you, building suppression signals, lowering corticosterone baselines, becoming a dopamine cue in a wild animal's reward map. The bird that stays when you approach is not doing something simple. It is doing something that required its brain to build a specific, individual model of you, your face, your movements, your patterns, and store it in long-term memory, and recall it faster than its own alarm system every single time you appear. That is not a small thing. That is one of the most specific and deliberate forms of trust that exists in the animal kingdom, and it was built one encounter at a time in your yard. Tell me in the comments, what is the moment you remember most clearly? The first time a bird stayed when it used to flee? I want to hear the specific story. I read every one. These are the ones I carry longest. I'll see you in the next one.